Hello! In this video, I'm going to show you how to create an amplitude to color visualizer. This patch uses multiple instrumental tracks to not only play them out, but get the amplitude and turn the amplitude data into colored panels, where the changes in amplitude is reflected in the brightness and lightness of the color in real time, creating a nice audiovisual effect. This video is also going to be an introduction to the MSP side of things in Max MSP. We're going to see how to import audio files, how to get sound out, how to change the volume, and most importantly, how to get more data out of the audio so we can do cool, creative things with it. So let's begin. It is very straightforward to import audio files, sound files into a Max patcher. All you have to do is to find that file on your computer in your file browser and then click and drag that file into the patcher. This will create a playlist object with that file already loaded in. And I'm going to do this with all of the files separately because if I select all of these files, drag them together into the patcher, it is going to create a single playlist object with all the files loaded in, and that is not what I want in this case. I like to have these files in the same folder as my patch so that if I put them in here, then I save the patch. Reopening it will automatically load these files back. They will be automatically found by Max, which is really convenient. Now, if I'm going to play these, if I'm going to try to get some sound or other information out of these, there are two things I need to consider. The first is that I need to go to Options and Audio Status, and I need to check my input and output devices. Right now, the input device is the microphone with which I'm recording, and the output device is a multi-output device that records the outgoing sound and also plays it through my headphones so I can hear what is going on. In your cases, this is probably going to be a different thing, but it is always good to check if these devices are set correctly. If there is no sound coming out from your patch or if the microphone input doesn't work, this might be the problem. Another thing to do is to turn on the audio context, the audio engine. You can do this by clicking this on-off button at the bottom right. If it is off, it is going to be gray, and if I click it, if it's on, it is going to be blue. Now, even though the audio context is on and the audio options are set correctly, these are not going to work. I can lock the patcher, I can click on these play objects, and it is technically playing, but I am not getting any sound. That is because playlist does not play the sounds. It simply sends out the signal, the audio signal from its outlets. The first outlet is the first channel, I believe that's the left speaker in a stereo system, and the second outlet sends out the second channel's audio signals. We still need an object that is going to play these. A very simple and very easy, dare I say, object for this is easy DAC, easy DAC, with a tilde at the end. By clicking on this object, you can also toggle on and off the audio context, so you can see if it's off, if this icon is switched off, and if it's blue, it means switched on, and so on. But what this object does is that it takes audio signals and it plays them out from your defined audio playback device. The left inlet expects something to be played out of the first channel, usually the left speaker, again if I have it right, and the second one is for the second speaker, so this object is set for a stereo environment. So I can simply take the first outlet of all these objects, connect it here, and do this for the second outlet. And then I'm going to, well, first align these, of course, and then I'm going to create a toggle so that I can start playing all of these at the same time. Now, if I'm right, it might be a bit loud. That was indeed pretty loud. What I want to do then is to turn down the loudness, turn down the volume of these audio signals. Now, a very simple way is again to go back here where I turned on the audio context and click on this audio meter gain. This lets you set the volume of everything in the max patch. It's all the sounds, all the signals of everything. So it is not usually good practice to use this to change the volume of the patch because it's going to be reset every time and it doesn't tell you much about what is being muted and why it's being muted or why you are changing the volume. A good way, good practice in my opinion, is to use gain tilde. Gain expects an audio input as an input, a single audio input. And then according to the setting of the slider, it scales that input. So if it's all the way off, there is nothing coming out of it. If it's, I believe about here, I'm going to be more specific in a second, it sends out the normal information. And if it's all the way up here, it is going to be even louder than the original audio signal. Now we are working with two channels, so we can think of this as two pipelines. What I'm then going to do is to create another gain. And I'm going to try and synchronize the settings of these two gains. For this, I can use the second outlet, which sends a slider value as an integer number. If I create this, connect it to the second outlet, you can see that it sends out a number for the setting of the slider. So I believe, 0 is nothing, 127 should be the original sound, and then it goes all the way up to 157 for an even louder sound. I can take this number and I can give it to the second gain. If gain receives an integer number instead of an audio signal, it is just going to set the slider to a value instead of to process audio. This way I'm just clicking on the left gain right now, but it is setting both gains. This makes it very convenient, very useful to work with multiple audio streams and set volume of multiple audio pipelines simultaneously. And if I wanted, I can just go to the second one and I can kind of fine tune it like this, which can also be pretty fun, pretty useful. But I think in this case, I will just set the volume altogether. Now, the only thing left to do is to connect this to this pipeline. So I can delete all of these patch cords and I can make some room here. I'm going to connect the first channel's signals to the left one and the second ones to the right one. There we go. Let me align it a bit better. And then the outlets, the output goes to easy. It goes to easy DAC, easy digital to analog converter. And now take a look at how it sounds. Great, so we managed to create this rudimentary simple audio player playing multi-track stems of a song, combining them together and sending them out through speakers or any kind of audio output device. This was the first piece of the puzzle, right? Now, what we want to do is, of course, we want the second piece. So I want to create a colored panel, a panel that will change colors based on numerical input. This is something I have done in the very first video. You can always check that out if you're interested in that video. I use that to connect it with a MIDI keyboard to change colors of a panel according to which note is coming in. And I'm going to do something similar here. I'm going to create a panel that I can change its shape and I can move it around if I want to. And I'm going to create swatch, a color picking tool. The output of swatch is going to go through prepend BG fill color, the attribute of panel I want to change. And if I send it there, as you can see, picking a color from swatch affects the color that is being changed. This is nice and all, but what I'm envisioning is that the color stays the same, but the brightness changes with the amplitude of the music. The beat of the music makes the color appear brighter or darker. So I need to tell swatch colors in a way, or brightness in a way that is different than the RGB color space. I want to create pack and then type in the message HSL and then 3 values. One for hue between 0 and 1, one for saturation between 0 and 1 again, I'm going to put 0.5, and one for the lightness, for which I'm going to put again 0.5. Now if I connect it here, I can create a floating point number box connected to the second inlet, meaning that the second element of the list is going to be changed. So the first one changes HSL, the second one will change to 0. And now changing this number is going to change the hue. I can do the same with the other values. I can change the saturation, 0 making it completely gray, 1 making it very, very, very bright. Well, not bright, but saturated. And I can also just change the brightness here, 0 making it black and 1 making it completely white. And this is pretty much what I want. I just want the beat to change its brightness. I want it to change the brightness between 0 and 0.5. I don't want it to get too bright. Before I do this though, I want to set a color for each instrument. I have keys, I have the bass, and I have percussion. So for the keys, I want a tealish color. So let me first find that color through this. Let's fix these values as well. Okay, so I want this color. And I can see from the number I've put in that 0.43. Let's round it up to 0.45. I can put in pack HSL 0.45, 0.5, 0.5, making this the default message. So now if I change the brightness, the color message is going to be on the hue message is going to be on this nice teal color. I can even use load bang to make sure this color is sent to panel the moment I start the patcher. Load bang sends out a bang message from its outlet the moment the patcher window is opened. So it's useful for setting default settings, turning certain settings on or off the moment a patcher is loaded, and here I can just send it to pack so that it just sends out the list without making any changes, going through swatch, going through prepen, arriving at panel, setting the default color. Great. I am going to copy and paste this 2 more times so I have a panel for all 3 instruments. But I do want to give each instrument a different color. So let's see, for the bass, I want a brownish color. Something like this, yeah, 0.07. So again, I'm going to set it here, 0.07. Of course, this does not send any message out. I have to send a bank. I can also lock the patcher and double click on load bank to send a bank from here. And that will send it to the default settings, I believe. Doesn't seem to be doing it though. Let me check it. No, it is. Why isn't it changing it? Because I changed the value here, making it so that the internal message has 0.11 at the end instead of 0.5. So false alarm, everything is good. I can just redefine this object. Now double clicking load bank is going to set the color correctly. Okay, and for the third instrument, which is the percussion, I want the red color, just a standard red, which is 0 in HSL color space. The hue is 0. So I can just type 0 here. I can just load bang again for convenience, and there we have it. Okay. So now we have our colored panels. We can change the brightness of those colors by using these number boxes. The only thing we need is to somehow connect the output of this audio to get the amplitude of the audio signal and connect it to these numbers. To do this, I am going to use peak amp tilde. What peak amp does is it takes a single audio input, so I don't need to put 2 channels, but a single channel. And it expects a bank, or it expects an argument in milliseconds. So if I type 50, each 50 milliseconds, it's going to give me the amplitude of the audio, amplitude of the sound. And it's going to do this in a floating point number, which is very useful for my purposes. See what happens if I just play the keys. it's a very fast stream of data, but it's reflecting the amplitude of the audio signal that is coming through. So we can use this. I can, in fact, immediately try to plug this output of pcamp into the right inlet of pack. Or I can just put it here in the number box so that we can visualize the number. And let's see how it looks. Okay, we are getting there. So first of all, I noticed that the numbers are going from 0 to 1, and this makes it go closer to a completely white, bright kind of color. But I want it to be between 0 and 0.5. So I can, if I want, I can use a simple mathematical operation, right? I can like type minus 0.5 and I can put it in this pipeline, and now it should technically work. But this would not be very good practice because the resulting values sometimes go below 0. And Swatch interprets this as 0, it just clips at 0. But a better way would be to just maybe half the number, maybe divide the incoming number by 2, or more simply just use scale. Scale is one of my favorite objects in Max, a very versatile, incredibly useful object. And scale needs 4 arguments. First, it needs a minimum and maximum of the range of the incoming value. So in this case, I'm receiving values between 0 and 1, right? So I can type 0 points to make it treated as a floating point number, and then 1. And then scale expects 2 numbers for the range of the outgoing, the result of the scaling. So to which range do I want to scale these values? Well, I want to scale it to 0, I mean something between 0 and 0.5. And now if I do this, the resulting sounds, the resulting numbers more accurately, are going to be between 0 and 0.5, giving it a nicer color, a nicer brightness, closer to what I want. And you can always tweak these settings, see if it could be 0.7 or even 0.1 to get different kinds of values. Of course, another thing is the fact that it is a bit janky right now. The values are all over the place. They change so quickly, they change so much that it does not look very good. It could look smoother. We could smooth out the changes, the variations between these values. And for this, I like to use slide, which will smooth values logarithmically. And slide requires 2 arguments. It requires the amount of the slide up and amount of slide down. By default, these are 1, and you can again try different values. Slide up and slide down here means how smooth this motion is going to be. But this, of course, comes with a cost. The higher these arguments are, the higher these numbers are, the smoother the transition is, the less reactive it's going to be to the incoming data, the incoming value. For example, if I write something like slide 3.3, and I plug it here, right, between pcamp and scale, this should immediately look better. But if I type in something really high, let's say 30 and 30, look what happens. It's really slow. The values don't even go that high because they are moving so slowly. It is difficult to see the changes. It becomes less audio reactive. So for this patch, I'm just going to type in 3 and 3, but for your own purposes, you should also tweak around with this number. Now, all that's left is to just copy and paste this and connect it with these audio, this playlist outputs. But what I want to do is to use send and receive objects to not connect objects all over the patcher. I don't want the patcher to look messy. It's really important. It's good practice to make sure the patches are understandable, they're simple, and it doesn't look like a big mess of spaghetti on your screen. To send and receive signals, to send and receive data in Max, instead of connecting things with cables, you can also use send, or S for short. And then you have to type in a name. So I'm going to type in, let's see, keys. Now, if I send something to this keys object, the S keys object, any object named R keys is going to receive this value. Right? So now if I play this again, the values are going to appear here. This is the same thing as connecting the output of scale to this number box. But there is no cable in between, which makes it possible to have better, nicer looking patches. So let's do the same thing for the other audio files. I'm going to call this bass, obviously. And this one's going to be perk for percussion. And I can just connect it here and here. And now I only need to create the appropriate receive objects. Let's see, this was bass, I believe. Yes, that was the bass. And then the percussion. Okay, let's try it out. Cool, it looks really cool. And there are so many possibilities with this kind of patch. You can try to put these values into other parameters, like for example, have the color change, the hue itself change, or the saturation change, or multiple things change. Or maybe they could change at different rates. You can use different scale objects to have different lines of change, different lines of scaling between values, and you can put that into these pack objects. If you create music, if you create sound, if you know or like using DAWs, you can create your own tracks, export the multi-tracks, the stems from that DAW, and try something like this. Create a nice, neat color visualizer. Most important thing is that you do something creative and you have a good time with it. I hope this was useful to you, and thank you for watching.